All right, the floor is yours.
Awesome, thank you. So let me go ahead and hide everything incriminating, and then I will share out my screen. Is that coming through okay for everybody?
Yeah, it looks good to me.
Okay, perfect. All right, so hey, good evening, everybody. David Christian here. Super excited to be talking to you today about PowerShell and AWS. So before we jump into it, just wanted to kind of give a quick introduction on myself. So I've been playing around with PowerShell enthusiast, probably since about 2009. So prior to doing PowerShell, I was a big VB script guy. And I remember the first time I saw PowerShell, it just blew me away, right? You know, how this much VB script could be kind of condensed and optimized in just a couple of lines of PowerShell. And I've been hooked ever since. So I've been playing since I think it was version 1, a huge user of version 2, and then, you know, obviously the later ones as we went on. I also run a blog, overpoweredshell.com. Not as active as I used to be, but a lot of information on there. A lot of the code snippets that you'll see today are coming from that blog. So what I actually do for work, though, is I've held a couple of different jobs over my career. I'm a security major, started in security, wasn't a big fan of it. So I moved out of security, did a lot of systems engineering. That's really where I fell in love with PowerShell. Previous life, worked for a mortgage loan origination company where we ran the DevOps team, did a lot of cool stuff there as well. Heavy users of PowerShell, DSC, and really where I was able to learn my build and automation skills. And then currently I work for AWS. I am a enterprise solutions architect for AWS, helping some of AWS's largest customers. At AWS, I do focus on what's called the builder's experience. So builder's experience is things like DevOps, CI/CD, infrastructure as code, and chaos engineering. I do want to point out, even though I do work for AWS, this is an AWS and AWS and PowerShell presentation. All thoughts and opinions are my own here, so quick disclaimer. And then all the code that you can find for today's session is available on my GitHub, dchristian3188, PowerShell and AWS, and I can send that a link to that after this. And then I always like to end with a fun fact. So fun fact, if I'm not in front of my computer, I'm behind my guitar. I think it's important we all step away for a while and have hobbies or do things that involve us not just sitting here. Anyway. For those of you who've never been through a presentation with me, just know I like to keep these things super casual. If at any point you have a question, please feel free, jump in, interrupt me. You're not going to hurt my feelings. I'd really love this to be a conversation instead of me just, talking at slides or walking through some different code options for you for the next hour. Cool. So let's jump right into the presentation. I'm breaking up the presentation into a couple of sections. And the first section is really what I like to think of like the getting started section. So this is where we'll talk about how to install the tools, we'll set up some credentials, and then we'll actually work and configure our shell. Go ahead over to VS Code here. Is this small? Do I need to make the font bigger, or is this okay for everybody? Looks good. Okay, cool. All right. So first off with the PowerShell commandlets, PowerShell commandlets do run in PowerShell core. So that's nice, right? Especially if you're trying to do things cross-platform. I'm on my Windows PC right now, but for work, I actually use a Mac, so having access to the same commandlets is super nice and super powerful. And for those of you who played around with the AWS commandlets, they've actually gone through a couple of different iterations. So the first iteration of the AWS tools was this big monolithic repo or monolithic package that had every command for every service as part of it, and it was just this huge download. That's changed. You'll still see some references out there, but the new AWS modules are under this AWS tools.prefix. So if you do your find module and you look for AWS tools, you're going to get quite a few different packages. And I think the last time I checked, it was over 200. 260, so they've added a couple. So the idea with this new approach to handling the modules is there is a couple of common modules, and then the modules for each AWS service are going to be broken up into their own kind of commandlets or separate modules. So this is super nice, right? So you can only install the things that you need. You can keep your build images slimmer, and you can be really, really focused on what you install. So the first service or the first module that I wanted to cover is the AWS tools.common. So let's go ahead and let's install this one. Should already be installed. Now, as you may have guessed, the tools common has common commandlets that are going to be kind of applicable for the rest of our work with the AWS commandlets, and they really kind of revolve around setting up your shell and then being able to authenticate and access AWS. So if we run a get command for the tools common module, some of the important ones, right, is adding your AWS credential, setting your region, right, setting your profile. So everything else you do is going to rely on that common module. And I'll walk through in just a little bit on how to actually set up that shell, get configured, but let's put a pin in that for now. The second module I wanted to talk about and that everybody should be familiar with is the installer module. So, speaking honestly here, I really do like the approach that AWS took separating out these different packages, right? It allows them to move quickly. It allows them to do functionality for specifically what you need. But managing your module versions is kind of a pain in the butt, if I'm speaking honest. Especially the way that module auto loading works, right? And a very common scenario that you may run into is that you'll actually have mismatched versions of different modules, right? So what can happen is you can have an older version of, let's say, the EC2 module, and by executing that command or a command in that module, the module will auto load. And if there's dependent modules such as common, that may pull in an older version. And then let's say you're using a newer version of another module and you try to import that one and it's trying to bring in common on a different version. It just gets ugly really, really quickly, and it's hard to manage. So the tools installer module aims to kind of overcome some of those shortcomings. So this module has 3 commands in it. That's it. The first one is install AWS tools module. So this is basically a wrapper that you can use to install other modules. Now, if we go back to the way our naming convention works here, everything is prefixed with aws.tools. So in the install-aws tools module commandlet, you can use the shorthand of just the service name to install those kind of subsequent modules. So what we'll do here is for the rest of the presentation, I'm going to be doing some EC2, S3, Lambda, SSM, CloudWatch, and CloudWatch logs. If you don't know what those are yet, don't worry, we'll talk about it. But just know that I need those for the rest of my presentation. So I'm going to go ahead and I'm going to install those modules. Now this will go out and this will find the latest version of those modules and make sure they're up to date. Again, it looks like they already work. I've run through this a couple of times. And then the last thing that I like to do is I always like to make sure my modules are up to date. So there is a separate update AWS tools module, and I believe this one supports a cleanup flag. How often you have to do that kind of depends. I like to do it at least once a day. That's probably just my OCD. But I like to make sure that everything is on the same version and I get rid of any kind of pre-existing or pre-configured modules. Any questions on setting up the modules or just kind of how to get everything installed? So far, so good? Cool. Like I said, if anytime you guys have questions, please feel free to jump in, interrupt me. So the first thing I want to do is talk about how to set up credentials. So before you can actually start using the shell, you need credentials. There's a couple of different ways to do credentials. So first, let me show you the not so great way to do credentials. So the first not so great way to do credentials is to actually create what we call an IAM user. So IAM is the service that handles authentication and authorization on AWS. So inside of IAM, you can create a local user account. Right? Think of it like a local user account on your machine. Now, by creating this account, you would assign some permissions to it, and then you can choose to generate credentials. One way to generate credentials for this user, especially for programmatic access for things like the CLI, the PowerShell tools, some of our SDKs, is to use these access keys. So I'm going to go ahead and create access keys. This is the only time you'll get to see an access key. So there is the access key ID as well as the secret. So think of it kind of like your username and password. I'm going to remove those. Now, what you could do is you could take those access keys and secret keys, and then you can embed them into your commandlet. And the way you would do that is with this set AWS credential -access key -secret key. And that'll persist those credentials inside of the shell. Now you can also make those credentials persistent. The way you would do that is by adding this store as flag, and you can choose to give it a friendly name. This is helpful if you have multiple accounts. There's a special name called default. Spoiler alert, makes it your default credential. And then any other time you would access that command, or you would access it and you don't specify a profile, it's going to use that username and password, or that access key and secret, I should say. I'll be honest with you, I'm not a big fan of that, just because it becomes something to manage, right? And you have to worry about when was the last time I rotated keys? Are they safe? Am I putting them in a known location? Another method of using those long-term keys is to actually store them in a config file. But again, this is a configuration file that is in clear text, available on your machine for anyone to access if they were to get that credential. So a better way to do it is to actually leverage kind of short-term credentials inside of AWS. So using AWS organizations, you can create federated users. So I'm logged in as my federated account. And from here, I get temporary credentials. So this is configurable on how long these credentials last. But I will choose this set of credentials. And you notice up at the top, we give you some kind of commands that you can run to get these credentials loaded up into your system or into your shell. So we're doing PowerShell, so I will copy those PowerShell commands, and then I will paste them into my shell. So at this point, I have these environment variables that are set that the rest of my session will use anytime it needs to access any AWS resources. Now, the next thing that we want to set up before we actually get going or actually start working with any resources is we want to set up our region. So AWS has multiple regions that resources are available in. I am going to choose US West 2, which is our Oregon region. And what I'll do is in this shell, I'm going to set my default region. Now, as you work with any of the AWS commandlets, region is always a property that is available. It's just one of those things. I know I'm going to be doing everything in West 2, so I'm not going to have to go ahead and specify West 2 for every commandlet. Just makes it a little simpler. All right, so at this point, we should have our shell configured. We have our temporary credentials loaded, and then we're set up in a default region. Before we get going into our next section, any questions? Cool. So the next thing I wanted to talk about is working with EC2. So EC2 is AWS's elastic compute service, right? So think of it as running virtual machines on AWS. We have quite a few different options to be able to run these instances with lots and lots of configuration. So I will show you some of the more important configuration, specifically how to set up authentication, how to do your security, how we can actually provision machines, and I got some cool tips and tricks for EC2. And I understand not everybody may have a ton of AWS experience, so I'll try to explain things as much as I can as I go. But again, if you do have questions, please jump in and let me know. So the first thing I want to do, or I want to focus on as we start talking about EC2, is I want to create a key pair for us to use for our machine. So I'm going to create a new key, and I'm going to call this key SoCal Posh Demo. So the way I would create a new key pair is this new EC2 key pair, and we give it a name, and it's going to go ahead and it's going to output a certificate. So what's happening behind the scenes is when you create a key pair, the public key and private key are generated, and then the public key is uploaded to AWS, and you have the private key. Now, whenever you're working with credentials for an instance, those credentials are going to be encrypted with that public key. And the idea is that since you have the private key, you're the only one who's going to be able to get those credentials. Now, this works slightly different depending on which operating system you're using. So if you're using a Linux-based operating system, this private key is what you'll actually use to SSH into the machine, and then we're going to add that public key as kind of that SSH user. On Windows, you actually use this private key to decrypt the administrator password, and that's how you'll connect. And I'll show you a little bit about that in a couple of minutes here, but just know that we're using this key pair to be able to get our credentials for our machine. Now you notice that this key pair was only generated and outputted to the screen, so I did make sure to grab that as a variable, and I'm going to go ahead and I'm going to save that key pair locally here. So I have my private key here saved, and we'll be referencing it in a couple of upcoming slides. To see what that actually did is we'll head over to the EC2 console. And we'll look at our key pairs. So again, here's that same key pair that we just generated. Here's the fingerprint for it. Again, the public key has been uploaded. We have the private key, but we can now reference that as we go ahead and provision machines. All right, so the next thing I want to do is I want to actually configure which VPC and which security groups my instances are going to run in. So if you've never heard of the concept of a VPC is a virtual private cloud. Think about a VPC as your private data center running inside of AWS. So VPCs are fully contained, they're fully isolated from other customers, and they're even isolated from other VPCs in the same account, right? So if you're running a VPC or two VPCs in an account, unless you explicitly configure it, there's no communication that happens across those VPCs. So the first thing I want to do is I want to get a list of my VPCs. So inside of this account, I have two VPCs. I have a VPC that was provisioned as part of my account vending. And then I have what's called a default VPC. And the default VPC is just like it sounds, that if I don't specify a VPC, it's going to be the one that machines get automatically placed to. So I'm going to go ahead and grab a reference to that default VPC, and I'll store that there. The next thing I want to do is create a security group for my instances. So when you provision instances, they need to belong to what's called a security group. And you can think of a security group kind of like a little virtual firewall that lives around all of your instances. By default, there is a default security group, but it's pretty permissive. It allows everything else in that security group to be able to talk to it. It doesn't allow any outside communication, but it's not a best practice to use that security group. So what I want to do now is I want to create a new security group. So I'm going to call this security group my SoCal Posh Demo group. And this group is going to be specifically to give myself admin access into those machines that I'm provisioning. So how do we create a new security group? New EC2 security group, right? The commands are pretty well named, so we'll be able to go with that. And then how do we get it? We'll do our get EC2 security group. So here we see that our security group was provisioned, gave it that group name, and then it's associated to that default VPC. Now, if we were to come back into the console, we should see that security group here. But one thing that you'll notice on this security group is that there's no inbound rules. There's outbound rules. So by default on a security group, all outbound traffic is allowed. And we do that, right? So if you have a high order ports or anything that need to communicate return traffic, it's just going to work. But by default, inbound traffic you have to explicitly define. So what I want to do now is I want to go ahead and I want to modify that security group. And I'm going to add two rules. The first rule I'm going to add is I want to enable RDP traffic. And specifically, I want to enable RDP traffic on 3389 on the target server, and I only want to allow that coming from my public IP address running at my house right now. So the first thing I'll do is I'll figure out what my public IP address is. We have that stored. And then next, I'm going to create an instance of this IP permission object. So what we'll do is we'll create this object and we'll set some of these properties, right? Again, the most important ones are our from port and to port. And then I'm going to lock down and say that this is only allowed from my public IP address with a /32 subnet mask, basically says just this IP. And then I'm going to do the same thing for WinRM. So I want to be able to WinRM into my instances from my home computer. So right now I have two of these IP objects. If I were to look at them here, there's my RDP one and there's my WinRM one. The next step, or the final step then, is we have to associate those IP objects back to our security group. We'll grant those access, and then if we were to look at our security group, we do see these two rules were added. We can come back into the console and we should see the same there as well. Perfect. All right, so now that we got our key pair set up and we got our security rule set up, we can actually start, provisioning some instances. So the first thing I want to do, or the first thing I did when I was getting started with the PowerShell commandlets, is I'm looking for an image. Well, there's a get EC2 image commandlet. Let's see what that one does. And you wait, and you wait, and you wait. There is quite a few images returned back from running this commandlet. I checked over the weekend. Over the weekend, there was 124,000 images available in the US West 2 region. So I'll give that another few seconds to load. It's thinking about it. Still thinking about it. There we go. So when you run this get EC2 image command, this is the information that you get back. Probably some of the more important details here, right? Things like the platform, whether it's Linux or Unix, Windows, the image location. Image locations usually give you a pretty good insight about the name, right? Or the type of image. Same thing with the name. The name's usually pretty close to that. But you guys saw how slow that command was, and there's 124,000 to sort through. There's got to be a better way. So the better way to do that, unless you explicitly know your image, is to leverage SSM's latest image search. And let me pause here. Because there's so many images, it is difficult to find the latest one or the right one, whatever the right one happens to be in this context. And more to the point, AWS is constantly adding new images. So think about for all of the flavors of Windows that are out there. Every month, what we'll do is we'll apply the latest security patches and fixes to those images, and then we'll publish those as the latest version. So you can tap into that, and using this get SSM latest EC2 image command, you can say, what is the latest versions for Windows? I don't care that you got a version of 2012 from 3 years ago. What's the latest one right now that I should be looking at? So running this command here will actually focus us on just the latest Windows images. So again, already you can see that it was much, much faster, but I'm still seeing, a lot of things that I don't care about. Some different languages, some different versions of Windows. Let's filter this down even more. So I'm looking for a Windows 2019 image, I'm looking for English, and I'm looking for the base. Okay, cool. So that definitely helped, right? So now we have a couple of different versions. We have the core, which is Windows Core. We have the full, and a couple of other different kind of special configurations. But you know what? I'm pretty confident this English full base is the one I want. Now, probably wondering, why are we spending so much time on the images and finding these AMIs? Well, it's important that you're able to programmatically get the AMI image. And like I said, we publish these images in different regions. And even though that this may be the same image, it's going to have a different AMI ID in different regions. To show you what I'm talking about here. So here's that same image, right? But the first time we'll run it, or we'll run this command, this is the version in US West 2, which I have as my default. Here's what it looks like in East 2 and then East 1. Notice they're all different. So if you have any type of automation or scripting that relies on a hard-coded AMI, as soon as you move that to a different region, it blows up, right? So being able to find programmatically what image you're looking for, super, super powerful. Any questions on that? Or anything that we've covered so far on the EC2 images? All right, we'll keep on trucking. One of the next pieces of information that we're going to need is we're going to need to know what size of image to use. So there is an instance type switch available on the commandlets. And if you do your IntelliSense, you'll see that we have quite a few different image types to choose from. So with AWS, there is a method to this madness. We do have a naming convention. Usually the first letter is going to tell you what type of instance it is. There's some little helpers here, right? So the way I like to think of C is for compute optimized, M is for memory optimized. We have these T3, these are our burstable instances. So that first letter is really kind of the family that it belongs to. The next one is the number. The number is going to tell you the generation of the instance. Obviously, an older generation is going to be the newer, fancier instance. It's something that you want to go with. And then you may see modifiers after that letter and number. For example, G lets you know that this is a 6th generation memory optimized Graviton or ARM processor, right? This N over here is for networking. So that's an instance with advanced networking capabilities. Basically what I'm trying to say is depending on any workload, there is an instance that matches it. So finding your right instance and being able to decipher this is going to be helpful as you start to provision machines. So we will choose a T2 large. So I'm going to be a burstable instance. So we'll keep that in our back pocket. And before we actually provision a machine, I wanted to talk about how do we pass data into that provision machine. So we have this concept of user data. And the way user data works is anything that you pass into user data is going to be executed once that machine starts up. So for my example, what I'll do here is I'll actually disable the local firewall. So I'm going to provision the machines. I'm going to disable the local firewall. I'm already having the security groups on as a kind of safety net, so I know that only that traffic is going to be allowed. But that way, just to kind of smooth over any connection issues that we might have for the rest of the demo. Now, basically, you can put any PowerShell script in here. Hint, hint, if you're looking to bootstrap with a pool server, this is a great place to do that, where you can actually set your configuration, point to your pool server, or if you had a local kind of push, you could do it that way as well. But this is where that goes. Basically, what you do is you create a string and you wrap the string in these PowerShell kind of brackets and annotations here, and then you go pass it into the actual command. All right, been talking a lot about it. Let's actually do it. So to start an instance or provision a new instance, first thing I'm going to do is I'm going to get my latest AMI image. And then we're going to start a new instance. This instance is going to be a T2 large. It's going to use that security group that we provisioned earlier. It's going to use that key pair that we provisioned earlier. And then it's going to execute that script once it starts up. So let's go ahead and run that. All right. And if we take a look at our console and we head over to instances, I do have a new instance, and that instance is pending. Looks like the size is lining up, so I think we're good there. So we'll give that a second to bake. I know I went through it kind of fast, and I want to point out that I in no means touched on all the parameters that are available in the new instance command. If you look at the new instance command, there's 76 parameters. So if you're looking for certain settings, configurations, options that you can change, more often than not, it's going to be in there. So no, this is a kind of a small subset of the things that you can do. A lot of this, though, is available through the rest of the switches or other methods. But no, definitely you have the flexibility. Anything you can do in the console, you can do here. All right. And we can also obviously do cute things like provision multiple instances. Right, so I'm going to execute that same command, but let's do it 5 times this time. So we'll spin up a couple and let that go. And if we come back into our console, there we go. We have 5 more instances pending. All right. So now that we have our instance out there, doesn't do you any good if you can't interact with it. So if you were using the console, the way you would interact with this is you would download a remote desktop file, and this remote desktop file would have the public IP address of the machine. The username is administrator, but then there's this get password, right? And the way you get password, once your machine is updated, let's give that a minute to bake here. There we go. So once the password's generated, what you would do is you would upload that private key that we talked about. There's my private key. And then using that, oh, come on. Give me 1 second here. The demo gods are not with me. We do. one more time. There we go. So using that private key, what you could do is you could upload that and you'd be able to decrypt the password. So now you have a remote desktop file, you have your public IP address, you have your username, your password, and then you use that to connect. That's okay. There's a better way. Let's actually go through it. So first thing that you can do is you can get that same password, or that same password information using this get EC2 password data command. Now you notice that it's kind of goofy. It doesn't just work the way you would expect it to. So I have an instance here on my keyboard, or in my this variable. There's an instance, but the way the objects are kind of nested, you have to expand them out. You can't just type directly into it. So from there, you can get your different instance data, expand it out, and then if you pipe all of that into our get EC2 password file, boom, there we can get the password the same way. Again, that's okay, but I wasn't a really big fan of that method. So one of the things that I did is I wrote this helper function called get EC2 credential. And basically what this function does is first it knows how to handle that kind of goofy input coming from the get EC2 instance commandlet. But more importantly, what it'll do is it'll get the password data, that same command, and it'll actually create a PS credential. So once you run this command, the output of this command is a PS credential object that then you can start using in different places. So let's see what that looks like as we start kind of taking this up. So we'll load up our helper function. And now let's run this get EC2 instance. And notice instead of getting just the raw password file out, we now have that PS credential. Okay, getting better. I can work with PS credentials. So the next thing I wanted to do, or I wanted to kind of simplify, was working with RDP. So you saw where you can download the RDP kind of file there, but you still have to fill everything out. You still have to kind of decrypt the password. So previously, in a previous life, I used this function called connect MSTSC. It's available on the PS gallery. I forget the gentleman's name who wrote it. But essentially what it does is it allows you to provide a IP address and a PS credential, and then it'll create a RDP session to that machine. So I'm like, okay, that's pretty cool. What if we were to wrap that same process of getting an EC2 instance, generating the credential, and then using that generated credential to connect to our machines? So you see here, this one again knows how to handle that funky output or that funky input and unpack it. And then from there, it'll grab the public IP address of the machine, check to make sure that we do have a public IP address, grab the PS credential, and then connect to that machine over RDP. So if we were to see that whole process kind of play out, here's my instance, and we'll connect, and boom, just like that. Now I have an easy programmatic way to remote desktop into my machine. Don't have to worry about the credential, don't have to worry about decrypting it. Heck, I don't even see the credential at that point, right? And that's another thing that I like to point out. All of these instances have different credentials, right? So all of them are going to have different passwords. It's always going to be administrator, but if you don't join into the domain, they're all going to have that random password. All right, kind of cool. So let's go ahead, let's log off of here. I know what you're thinking. Dave, that's cool. You can RDP into a machine. It's a PowerShell user group. We don't do RDP. Everything is PS sessions. Okay, I got you. So next, I figured, Well, you know what? If you got a credential object, why not create a PS session? So again, very, very similar commandlet. Unpack some of that goofiness coming from get EC2 instance. We'll check for a public IP address, and then we'll find our credential, or we'll generate a credential, and then we'll create a PS session. So to see this one in action, we'll load it up. And then I'm going to say that I want to get all my EC2 instances that are running, and I want to generate a PS session for those.
We had a question in chat. How do you bypass the smart card?
The smart card.
I'm assuming they mean if there's a smart card requirement on the EC2 instance. Nate, do you mind clarifying? Yes, that's what he meant.
That one I'm not sure. I haven't played around enough with that or run across any instances that have that. Oh no, we're failing. The demo gods are not with me. What it is, I forgot to, I defined my, I showed you this, but I didn't actually run it. So I did not disable the firewall on those machines. Shoot. I still do have a machine here that firewall off. This one to do a new EC2 PS session. There we go. That's what I was expecting. Sorry about that, guys. Missed the firewall command earlier. But we can see here that the new EC2 PS session did work. So I do have that session object available. And then, of course, at this point, right, everything else that you would expect from having a PS session, such as invoke command, everything else should just work. Perfect. All right, any questions on that side of it, aside from why my demo failed? Cool. And then I guess the last thing I wanted to point out here is that all of the EC2 commandlets do have basic, kind of life cycle rules, right? So things like, restarting an instance, stopping, all of that is available. What I'm going to do here is, because we are frugal, I'm going to go ahead and I'm going to delete all my machines to save money. So we will come back to our EC2 console, and we should see that they are all stopped now. And if we clear our filter, we can see that they're all shutting down and will be deleted. Cool. All right. So next, what I wanted to do is I wanted to jump into Lambda. And for those of you that are unfamiliar with Lambda, Lambda is AWS's essentially function as a service. So it is a serverless offering where all you do is you provide your code, and then AWS takes care of the rest. So we'll take care of the underlying infrastructure. There's no patching, there's no maintenance to manage. You give us a function or a library, we go ahead and execute it. So what we'll do is we'll create our first Lambda, and we'll walk through the process for creating a Lambda. One, using PowerShell, but also using PowerShell as the execution language for that Lambda. So I have a basic hello world that we'll go through. Next, I'll walk through a more complicated example of Lambda. And what we'll actually do is we'll set up an event or a Lambda that listens to events and takes some action. So it'll show you how you can do these kind of Rune Goldberg automation things. And then we'll talk a little bit about CloudWatch and how to view logs for some of these services. Right. So first off, with Lambda, we have our Lambda module, or the helper functions for the Lambda module, in a separate module. So that module is the AWS Lambda PS Core module. So let's go ahead and let's install that one. Now, the way AWS actually implemented PowerShell Lambdas is they kind of cheated a little bit. So technically, PowerShell is not a supported language, but .NET Core is, right? So when you run a PowerShell Lambda, what we'll do is we'll convert it to .NET Core, or we'll write some wrappers, put some wrappers around it to be able to execute it in .NET Core environment. So that's one of the reasons that the authoring process and the publishing process is probably a little bit different than if you were writing a Lambda in Python or Node.js. So just kind of keep that in mind as we go through the rest of these examples. If it looks a little weird, that's one of the reasons. So the first thing you want to do before you start writing a Lambda is you want to work with one of our templates. So if you run the get AWS PowerShell Lambda template command, you'll notice that there is a couple of different templates for some of your more common scenarios that you might run into when creating a PowerShell Lambda. We'll walk through we'll walk through one of the more advanced ones in a few minutes. But for now, let's just kind of focus on this basic PowerShell Lambda. So what I'll do is I will create a new Lambda project. It's going to be using that basic template, and we'll save it in this directory. Cool. So if we look at our basic PowerShell Lambda, we're going to get the little helper script up at the top. And then it goes immediately into your requires modules. So the AWS tools are already going to be there in the Lambda environment, but you still want to explicitly call them out in your requires for your Lambda to be able to take advantage of them. Another important thing here is that any other third-party modules need to be explicitly called out. And what it'll actually do as part of the packaging process on your machine is it'll copy that installed version from your local machine into the deployment package and upload it. And I actually do have an example of that for our next Lambda demo. So again, really, really important that you want to be really tight with your requires modules, both the name and the module version, or else it's not going to work. And then after that, you can really just start writing your Lambda code. Now, there is going to be two magic variables that are going to be passed into your code. The first one is Lambda input. So Lambda input is going to be an object. Think of this as anything that's the incoming event. So if you were to put this Lambda behind an API, this would be the incoming web request. If you were to put this Lambda behind an S3 event, it would be that S3 change event. It's going to be there as Lambda input. Lambda context is the second magic environment variable there. That's going to give you information about the running context of your Lambda, things like your account, things like the region, right? So if you need to do any kind of introspective lookup there on what's executing or how it's executing, you can use Lambda context. You're looking at the incoming event, Lambda input. And then from there, you would do any PowerShell script that you want. Now, the way logging works is logging's a little different. Anything that you write out to write host, right, it's going to go as output. The verbose is going to get picked up. Obviously, errors are going to get picked up. But essentially, if you want to give information back to the console, you just write it out. So I'll write host, and we'll say hello, SoCal Posh. And we'll go ahead and we will save that. So once I have my Lambda looking the way I want, what I'll do is I'll actually run this publish command. So we're going to publish our AWS Lambda. We're going to give it a path to our script, and then we'll give the actual Lambda a name. So the first thing it'll do is it's going to go ahead, it's going to look at our .NET tools. The .NET CLI is a requirement for this, but then you see there it's actually compiling it, and then it's going to go ahead and it's going to zip up everything that we need to execute that script in .NET Core with our corresponding modules. and then it'll update our Lambda code inside of the console. Perfect. And let's actually head over to the Lambda console. So here you see our Lambda. Couple of different options, right? Things that you can change, things like your configuration. If you had any environment variables, you can change your permission, you can change the network this isn't running in. This was a pretty simple Lambda, so we kind of kept it a little basic. Probably one of the more important things here is this ability to do test events. So you can come in here and configure a test payload and execute it. So I will update this test event. We will check our Lambda. So you can see here that that first line, if we come back to it, was our Lambda input, right? So what we passed into that. So there you see the key value 1, 2, and 3, which we passed as test input. And then here is our actual message that we published as part of the Lambda. And then the last kind of, or the other things in here, right, are just kind of information about the Lambda. So what was the request ID as it came in, how long did the Lambda run for, how much memory, and what your build duration was. Any questions on the actual publishing or the executing? Okay so far? Yeah, I'm not sure, to be honest with you. I haven't heard anything. I will say that the latest trend has been to convert it back into .NET Core, but I haven't heard anything. Any other questions? All right, let's keep on trucking then. So cool, we have the Lambda. I showed you how to run it in the console. Obviously, you can execute your Lambdas through PowerShell as well. Again, really powerful if you wanted to kick off some type of automation or some process. The way you would do that is you would invoke, I don't know why they called it LM and not Lambda, but you would invoke your LM function. And basically, you'd give it your function name. And then I like to do this log type tail because I want to see the logs that are coming out of that. So I will go ahead and invoke that Lambda. So you see that our Lambda was executed successfully. I got that 200 response back. And then look at my log result. Okay, cool. Maybe it's just some weird commandlet formatting issue. If I were to expand that out, nope, same thing. So unfortunately, the log message you get back out of here is base64 encoded. So if you did want to read that Lambda result, you do have to run it through this decode from base64. And there you go. There is that latest execution. So you get your console results here. In a few minutes, I'll talk about CloudWatch and some of the CloudWatch module commandlets. And I'll show you a different way to do that so you don't have to do the base64. But no, if you are just going straight out of reading those logs from invoke LM function, that is something you do have to work around with. All right, so I said I'd show you a little bit more advanced example of Lambda. So for a more advanced example, what we're going to do is we're going to create a Lambda, and this time we're going to use the S3 event template. Oh, is there a question? Yeah. Oh. Oh, how about that? You should be looking at VS Code.
Nope, still seeing the web browser.
Let me stop sharing and reshare.
Perfect.
Awesome, cool. All right. So yeah, for this more advanced Lambda, what we're going to do is we're going to use this S3 event template. And let me go ahead and open up this project. So just to kind of quick level set, for those of you who are unfamiliar with S3, S3 is AWS's simple storage service It is essentially object storage as a service. So think of it kind of like a file shared in the cloud. You have pretty much free reign to dump any kind of files in there, nearly unlimited storage. If you can run out of storage, we'd love to talk to you about it. But great for storing things like static assets, pictures, web backups, really anything you can think of. S3 is a great use case for it. So what I wanted to do with this Lambda is I wanted to create a process where as a user drops a file into an S3 bucket, or specifically drops a picture into an S3 bucket, I want that S3 bucket to trigger an event. And that event is going to go ahead and call this Lambda. So what this Lambda is going to do is going to get the bucket information and the file information, looking at that Lambda input. And then it's going to resize that image. So I wrote a little function here, set DC image, and basically what that'll do is that'll take the height and width of an image, and then it'll basically reduce it by half. So the thought process here is we're going to drop a file in an S3 bucket. That S3 bucket is going to trigger an event. That event's going to trigger a Lambda. Lambda is going to look at that event details, find what that picture was, resize that picture, and then save it back into S3. So probably the important things to call out again here, right? Looking at that Lambda input, figuring out what our bucket was, doing the actual writing, and then pushing it back. Okay. Let's go back to our main script here. And we didn't make any changes, but I'll go ahead and I'll publish that Lambda again. And we can see it kind of compiling all its different resources there. Give that a second. So now I'm going to head back over to S3. Actually, before we do that, why don't we look at S3 in the console? So like I was saying, S3 is our simple storage service, right? Obviously, if you wanted to get a list of buckets, there's get S3 bucket. The bucket that I am really concerned with is this S3 image bucket test. So if I were to try to create this bucket, I already created it. Perfect. Previously named bucket succeeded, and you already own it. Fantastic. So important to note, S3 buckets are or require a unique name, and this is a unique name across all AWS customers, across all AWS regions. So these have to be globally unique. So the command is smart enough there to know that I already ran this, and hey, I already have that bucket. Perfect. And just like some of our other commands that we looked at, right? You can use PowerShell to inspect these services and then make configuration changes. So a very common operation is checking to see if your bucket is encrypted by default. So we can type that get bucket and then check our get bucket encryption. And oops, I forgot to encrypt the bucket. All right. So again, PowerShell to the rescue. We can define what we want our encryption to look like and then go ahead and set that encryption scheme. And there we go. Now we have server-side encryption. Obviously, I was only setting this on one bucket, but if you needed to set this on all your buckets in the organization, these are commands are pipelineable, pipelineable word, support the pipeline, right? So for these kind of mass operations, these quick and dirties, these ability to audit your environment, super, super powerful here. All right. And not only is it powerful when we start thinking about, kind of the maintenance or the management aspect of it, interacting with the buckets is actually pretty easy. So first thing I want to do is I want to clean up and delete everything in that bucket. So I've been playing around with this demo a little while. I just want to go ahead and remove everything. Looks like the bucket was empty. Next, I have this pictures folder. So inside this pictures folder, I found some random cats and then a couple of pictures of my dog. So what we'll do is we will go ahead and we will upload all the files from that local directory into S3. Cool, so give that a second to upload. So now, when we come into our S3 bucket, here is my input folder with all of my pictures and my originals. Now it's already finished processing, but we see that what was also updated was all of our resized pictures or our slimmed down pictures. So that was actually pretty quick. So let's actually walk through how that worked and what happened behind the scenes. So one of the things that makes this happen is in AWS, we can create a notification rule. So here I have a notification rule that says anytime an object is created in my input folder, go ahead and execute a Lambda function. And then that Lambda function is going to be these S3 function that we just looked at, the one that does the resizing. Now, if we were to come into the console, we could definitely see the latest execution, how many times we ran that Lambda, how long did it run for, all of that fun stuff. We can also view the logs. So logs are available here in a service called CloudWatch. So CloudWatch is our central log location. We could definitely look through it inside of the console, but let's actually take a step back and let's do it inside of PowerShell. So the first thing that you want to do, or the first thing that comes to mind when you're interacting with logs, is this concept of log groups. So for example, everything in my log group or everything under this Lambda is going to be in this log group here. And we can go ahead and get basically the kind of same information or get information about the log group running this command, but it doesn't tell us any details. So to get details, we have to go into what's called a log stream. So the relationship here is log groups contain log streams, and log streams are basically kind of a collection of events for a Lambda or for whatever service. Traditionally, log streams are broken up into instances. So if let's say you have multiple web servers writing to the same log group, each instance would have its own log stream. So that's what you'll see here. And then inside the log stream, you'll actually see the log events. So from CloudWatch, we can use our log group. Okay, cool. Once we have our log group, we can get a log stream. And then once we have our log stream, we can actually use that log stream to get the different events coming out of it. Let's look at this one first. And the first time you run it, you'll see that the output is not incredibly helpful because we're using this model that doesn't know how to get expanded, or this class that doesn't know how to get expanded. So what you can actually do is you can actually expand that out into events here. And then from there, you can finally see what actually happened. So for one of these, looks like this was the 2836 image. We were able to find that, or we saw that incoming event. S3 downloaded that, and then my function resized it, wrote it back to S3, and then cleaned up its temporary files. I'm not too happy with this whole kind of process of finding the different log groups to streams to events. So I wrote another helper function that kind of unpacks this. This is our get CloudWatch last log event. Pretty simple function, but essentially it's going to do the same thing that we did in those previous commands. Given a log group name, find the latest log stream. From that log stream, give me the events. And this is helpful now because what I can do is I can just call it with that latest log group, and then I can see whatever the last invocation of that Lambda was and get some kind of heads up information here. All right. any questions on Lambda, CloudWatch, maybe S3 in general? Are we doing okay? Did I lose everybody? It's kind of hard. I can't see your faces. No questions? Okay, let's keep going then to our last topic. So our last thing that I wanted to touch on for today is I wanted to show you how you can create a CI/CD pipeline in AWS for your PowerShell Lambdas. So what I did is created a little bit of infrastructure using what we call the AWS CDK. And I want to pause here and talk a little bit about some best practices. So some of the things that I've demonstrated today involve provisioning resources, right? Things like creating the EC2 instances, things like creating S3 buckets. There's PowerShell commands that support those operations. So can you create instances that way? Can you create buckets that way? Yes, you absolutely can do that. Is that the best way to do it? No, right? And this comes back down to kind of a discussion that we have when you're talking about, general imperative languages, like when you're scripting, and then declarative languages, right? And I know this is a PowerShell group, so think about writing a script to provision infrastructure versus writing a DSC resource to provision infrastructure. So the infrastructure as code solution on AWS is a service called CloudFormation. So CloudFormation is a declarative language that defines what your infrastructure looks like. So for my CI/CD pipeline, I actually have this template that defines everything that's going to happen or everything that I need for my pipeline. Could I have scripted this out? Absolutely, right? We have PowerShell commands for all of this, but that means it is now on me to be able to modify that, handle exceptions, handle provisioning, deprovisioning resources. It just becomes a mess. So best practice here is to leverage CloudFormation and this declarative language to provision our infrastructure. Now, I like to think of CloudFormation as kind of writing a moth, right? If we're talking about DSC. Can you write a moth by hand? I don't know, probably. Should you do it? No. So it's good to know CloudFormation, but there is more abstractions on top of it. So one of the newest abstractions, released in about, I think it was 2018, 2019, is the AWS CDK. So whereas CloudFormation is a moth, right, in DSC, CDK is essentially your DSC kind of resource or your configuration file. So what happens is you run your CDK code and that gets compiled down into CloudFormation, and then CloudFormation actually applies. So this process will probably take about a minute or two. So let me go ahead and kick it off. The first thing I'm going to do is I'm going to compile my project. So my CDK project was written in C# on .NET Core. So first we'll go ahead and we'll do our .NET build, and then we'll do a CDK deploy. And then once this starts, I'll go ahead and I'll talk about exactly what it's doing. All right, so you see here, these are the expected changes for my infrastructure. Cool, we'll let that run in the background. So what I'm doing as part of this configuration is this is me defining what pieces need to go into my infrastructure to have a full CI/CD pipeline. So my thought behind this is first I'm going to want a code repository. So we'll define a code commit repo. So code commit is AWS's Git service, right? So if you use anything GitHub, Bitbucket, right? It is Git as a service available inside of AWS. So first thing I wanted to do is I wanted to create a Git repository to store my Lambda code. Next, I'm going to create a role that my Lambda can use right? Since I'm going to be using this Lambda to execute stuff, I don't want to have to provision that in my code. I'm going to go ahead and I'm going to do that here. Next, I'm going to set up a build project. So a build project is essentially my build agent, where I'm going to package up my Lambda and then use that build agent to actually deploy my code, right? So very similar to how we were doing the publish AWS command. You'll see where I do that in the build agent in a few minutes, but this is essentially provisioning the infrastructure to do that. And then finally, I'm going to go ahead and I'm going to set up a pipeline. So I'm going to set up this CI/CD pipeline using AWS Code Pipeline. Essentially, I'm wiring up that whenever I have a commit to this Git repository, that commit is going to go ahead and download the latest source. It's going to go ahead and trigger my build, and then my build is going to go ahead and publish my new version of the Lambda. Then a couple of other things in here. I need some access, so I'm going to go ahead and I'm going to provision this access for my different steps behind the scenes. So this is still running. Why don't we take a look at the console, and let's head over to CloudFormation. And we can actually see this being provisioned. So here is my PowerShell stack, and then we can follow the events. The events are very similar to what you're seeing in the console. And then here is a list of resources. So far, a couple of resources have been created. Again, could you do this all in PowerShell? Yeah, you absolutely could. Should you? No, you probably shouldn't, right? It is much easier to define your infrastructure this way in a declarative format, and then let the engine handle that undifferentiated heavy lifting of provisioning a resource, ensuring that resource is in the correct state. This will also handle any deletes or removals, which is nice as well. So whenever possible, leverage CloudFormation, leverage CDK to do this versus kind of, trying to script it all out or code around those different edge cases. All right, so while that's provisioning, let's head over to our code suite of tools. The first one I want to do is code commit. So here is my repository that I can use for my PowerShell Lambda. So the first thing I'll do is I will go ahead and clone my repository. So let's go ahead and, it's still running in our shell. Give us a second. Why don't we do this? We will clone our repo. It says we've cloned an empty repo. Yes, I know. Next, what I want to do is I want to change into my repo, create a new PowerShell template. Again, using that basic template that we looked at earlier. So let's do this one first. And then the last thing I did here was copy a build spec. So I talked about having a job that would actually compile our Lambda and then publish it. So this is the definition for that. Essentially what this file is saying is on my build agent, I'm going to run a PowerShell core command. That command is first going to install that Lambda PS core module, that one that we looked at earlier. And then once that module is installed, it's going to go ahead and it's going to publish my Lambda, give it a name, and then here's a role as well for it to use. All right, let's see. Looks like our pipeline is finished. So I can go ahead and files. Exactly. And once this kicks off, let me go ahead and show you what that would look like. So inside of our pipeline, here is our pipeline. First time it's going to fail because there wasn't anything in it when it was provisioned. So as this gets pushed, we'll see that it registered that new source. So it saw that I had a file checked into our pipeline. And then once that finishes downloading all of that from source, it's going to go ahead and it's actually going to start that action phase. So here you see source finished, and then now we'll actually start our code build. If we click on code build, we can actually get more information about what's happening. So let's go ahead and let's tail these logs. And again, just like you said, GitHub Action, Circle CI, a Travis, very, very similar concept, right? So here you see a first step we're going to do is we're going to go ahead, we're going to bootstrap that PS Lambda core module. The build agent didn't have it installed, so it's going to go ahead and install it, any required packages. And then next, you can see it actually publishing our Lambda. So very similar to what we were walking through inside of VS Code. It's going to go ahead, it's going to convert that into .NET Core. It's going to restore any packages that it may be missing. And then once that's all said and done, it's going to go ahead and push it, and we should have a Lambda that we can then execute. All right, let's give this a second to complete here. While this is running, any questions, anything I can double click on for anybody? Cool. It did look like our build finished and our pipeline also finished. So now if we were to come back and invoke our function, you can see that our function was invoked. Let's go ahead and there's our hello SoCal Posh. And just to make sure there's nothing up my sleeve, what we can do is hello. And we'll let that run for a second. And while that's running, let's go ahead and let's just start moving on our invocation. So we'll sleep a couple of seconds, we'll run it, and we'll see how long this actually takes for our new change to be out there. So we are currently in the source stage here. Taking a look at our details. Looks like we are currently in the build phase. Perfect. If you refresh it, it makes it go faster. I don't know if that's true, but I believe it. That's all that matters. All right, looks like that is now publishing. So since that is now publishing, we should see this change in the next couple of invocations here. don't want to hold everybody up while we're waiting for that. I know we are approaching time here. Is there any other questions, anything else that we can kind of click into? If not, that's all I had for today. You say how much faster? When you say the second method, what do you mean the second method? John, can you clarify what you mean there about how much faster the second method is? The built-in tool versus Posh DSC. What built-in? I'm sorry, I feel like I'm missing something there. What built-in tools are you talking about?
Oh, is he talking about deploying AWS infrastructure with like you were comparing it to writing a MOF at one point?
Mm-hmm. Yeah, no, the idea between comparing it to writing a MOF, it was more to kind of highlight the fact that how it gets compiled down, right? Using cloud and deploying EC2 and applying DSC. Yeah, so I haven't seen any DSC modules for AWS itself. I don't know if somebody out in the community has done them to actually configure resources, but I will say the kind of de facto standard is CloudFormation. CloudFormation is pretty fast, but honestly depends on what you're deploying. The language or the tool that I showed was CDK. CDK kind of sits on top of CloudFormation. It's not faster or slower because what happens is that gets converted into CloudFormation and then CloudFormation still gets executed. What CDK really helps and really accelerates is your ability to write CloudFormation. So instead of having to write hundreds and hundreds of lines of CloudFormation, you can write a few lines of CDK code and programmatically generate it. So that's where the real kind of speed comes in. I hope that answers the question.
Yeah, and just to clarify for anybody else who might be wondering the same thing, you wouldn't use CloudFormation to configure a EC2 instance. Those are two completely separate use cases.
Yeah, that's absolutely correct, right? You would use, so the way I would do it and the way I've seen it done is you use CloudFormation to provision your VPC and your networking and your database and your instances, but the actual configuration still happens inside of DSC. So like we had that example of how to turn the firewall off, that would very easily be bootstrapping a machine to your pool server. So CloudFormation will deploy the machine, and then it kicks off a DSC job to actually do the configuration.
For anyone who's familiar with it, CloudFormation is very akin to Terraform. It's just Terraform is much more cloud agnostic, has a lot of different options, and CDK and CloudFormation itself are specific to AWS.
We actually do support a CDK for Terraform now as well.
Oh, interesting.
Yeah. Yeah, so if you like CDK, the style of CDK, but you prefer the Terraform engine, that is a pretty popular choice. We also, I don't know if there's any Kubernetes people in the audience, but CDK also supports Kubernetes as well. It's called CDK 8s. So you can take that same concept to write Kubernetes configs, but random fact there. Cool. Any other questions?
I guess one question, because you said you're a solutions architect. So when you did, are you directly interfacing with clients as part of your role with AWS as the
I
solutions
am.
architect? Okay. So how we're actually in the process of using, or we were evaluating CDK at one point for some things we were doing in AWS, and we have a lot of pre-existing Terraform configurations for other services as well. So they were kind of balancing the like, should they use CDK? Should they write CloudFormation on its own, or should we configure everything in Terraform with ways that we were already doing it? So with your other clients, how often do you see them using like CDK versus bare CloudFormation templates versus something like Terraform without any of that involved? Like what's the more popular use cases right now, or tools that you see other people using?
Yeah, so I definitely see a ton of CloudFormation. I see quite a bit of Terraform as well. Um, and as the AWS guy, I think Terraform's a pretty fine project. I really do. It works well. If you have multi-cloud considerations, I think Terraform can be attractive. Um, I will say the downside of Terraform and the downside of CloudFormation as well is it's just so verbose. And that's what kills me about both of those products, right? CloudFormation or Terraform. That I have to be very explicit about exactly what the resources are and all the different intricacies and how they're defined. So I will say that recently we've been getting a lot of traction. I've been picking up a lot of different customer requests to talk about CDK. And again, whether you do CDK with CloudFormation, whether you do CDK with Terraform, whatever, but having that abstraction on top of the tools to be able to leverage real programming languages like Python, like C#, like Java, really helps accelerate that whole process. And then the next kind of benefit on top of CloudFormation is that the real nirvana, or I should say with CDK, is that since it is using a real language, you can then go ahead and package that up and then deploy that out to your organization. So you can say that this is my company standard ECS cluster with a database. And then me as a developer just have to go ahead and import that module, and somebody else has already done that heavy lifting. I just fill out a couple of parameters. When you can get to that level, it's CDK all the way. It just makes everything else so much easier.
That makes a lot of sense. What makes you say CDK is less verbose, or if you think CDK is less verbose than CloudFormation or Terraform, why is that? Because from my naive perspective, as somebody who's never actually used it in any extent, it looks a little bit more daunting because you're actually writing, like C# code or something like that. But I'm curious to know why it might be less verbose.
Yeah, so let me actually show you. So that CDK code that I had earlier, right? 73 lines. Probably less than 73 lines because there's some formatting, there's some, module imports, but 73 lines. If you look at the CloudFormation that generated 800 lines of CloudFormation. Now, some of that is brackets and things like that, but it's significantly longer. And the reason it's significantly longer is inside of CDK, we have this idea of constructs. And I'll give you an example. If you wanted to create a VPC, a working VPC, right? We need a VPC. Then you need to define your availability zones. Then you need to define your subnets. Then you need to define your internet gateways and your route tables, your NAT gateways, right? In CloudFormation, you have to be very explicit about all of those things, right? In CDK, you say new VPC. And if you don't give it any other parameters, we will choose a VPC architecture that is well architected, that is highly available, that is resilient, that is following best practices. Now you can take that default one and you can modify it, you can make changes to it. Maybe you don't want to be in 3 AZs, you want to be in 2, right? Maybe you don't want a NAT gateway. You can tweak it, but by default, we've embedded the best practices kind of inside of those constructs, so you can just get started and get going with them. Another example, if you were, and that's an example where I did the S3 to Lambda, right? Normally you would have to, in CloudFormation, create a role and associate those two. But by using CDK and creating that connection, it knows, and it's smart enough to say, oh, your Lambda's gonna talk to S3. Cool, it's gonna need permission. And then, oh, I should probably create a role for that. And then, oh, hey, by the way, best practices for this role is to scope it to these permissions. So it has a lot of that built-in functionality for you behind the scenes that allows you to get started very, very quickly.
Right on. That makes a lot of sense. So I had a thought pop into my head while you were working on the CDK stuff. Say I was hosting my CDK code in AWS code repos. Could you kick off a job with the build YAML in CDK in the code repo to build and deploy the CDK against the same AWS account that the code repo is living in? So like say you were defining AWS resources in that CDK template, if you will, could you build that and execute it in a runner within that same AWS account to deploy other AWS resources into that account, like S3 buckets or something like that?
Oh, 100%. 100% you can do that. And that's a very common practice and something we recommend, right? Great, you have CDK, but that should absolutely be checked in. It should go through a build process. It should get deployed out. And you can run that same pipeline against things in the same account. You could do it in cross account if you configure the roles correctly. But that is something that we see all the time. Here's where it becomes a kind of a chicken and egg thing. So let's say you have this pipeline to execute your CDK, right? Well, then that pipeline definition should be in CDK as well. So then you need a pipeline for that pipeline, but then what's going to deploy that pipeline, right? So at some point you do have to run it once manually to get it installed. But once you do that, yeah, absolutely, have everything checked into source, running it through a pipeline, take away your administrator rights and only give it to the build agents. That is the way that you want to do it.
Yeah, that's awesome, especially for people who are on the call and listening, like keeping everything in the same place, keeping everything in the same like infrastructure, if you will, right? You don't have to run your CDK deployments through GitHub or GitLab or something into AWS itself. You can keep it all contained within AWS. Is way better for organizational reasons and things like that. So that's super useful. No, those are all the questions I had. During all this, did anybody else who's still listening have anything come up? Feel free to shout it out or drop it in chat.
Cool. Well, if there's nothing else, I'll let everybody get out of here. Again, thank you so much for giving me the opportunity to speak to y'all. If you ever do have any questions or anything, please don't hesitate, reach out.
Where can they find you? I know I've linked your Twitter, but what would be the best place to contact you?
Twitter works, LinkedIn as well, or actually my email. My email is dchristian3188, just like the GitHub. So just like my GitHub at Gmail, that's probably gonna be the best place to get a hold of me.
Cool.